first shape, shape 1. The area of shape 1 is 4. Now what is Ix of the first shape? This is a rectangular shape, which means I know for the rectangular shapes I should memorize that the moment of inertia around its centroid is equal to bh cubed over 12. Now what is b here? Since I'm finding it around x, then b will be 1. It is always parallel to this x. So b is 1 here. So 1 times h cubed, which is 4 to the power 3 over 12, and this is basically equal to 5.33. Now what is dy? dy is the perpendicular distance between this centroid and the centroid of the whole beam. So this is basically dy. dy, guys, is always equal to the absolute value of y minus 1. Alright? So basically, guys, dy is the absolute value of this y minus this y. So I know that this y is 2, y of the centroid of the first shape is 2, and y of my centroid is 1. So basically it is 2 minus 1, which is of course 1. And then I can do the multiplication between 1 squared and 4, which is 4. And then I can apply the parallel theory that states that it is equal to 5.33. So Ix prime is equal to 5.33 plus 4. So it is 9.33. Alright? Now, for the second shape, I should do the same. So basically, the area of the second shape is 8. This is the area of the second shape. Ix of the second shape is bh cubed over 12. Now b here is 8 times 1 cubic over 12, which means it is 8 over 12, and this is 0.666. And then y of the centroid for this shape is equal to 0.5 minus 1, and absolute value is minus 0.5, and absolute value, which is 0.5. 0.5 squared, 0.25 times 8 is 2. And then I can find Ix prime, that is equal to 0.66 plus 2, which is 2.66. And the final step to find Ix prime is basically to sum these two together. Alright, so it is Ix prime of the whole beam is 9.33 plus 2.66. Guys, if I have a hole, let's say I have another shape here, a hole here, this will be shape 3. I will do the same, except, guys, I should subtract this Ix from the whole Ix, alright? So I should, like the centroid case, I should subtract the whole moment of inertia. Now, if I'm gonna do Iy, basically it is the same, except, guys, that it is about y prime, alright? So y prime is this one, this is y prime. So what I have to do is to find Iy prime, or Iy around the centroid for each shape. So guys, I will put the answer in red color. So here I should find Iy around Ci. Now Iy around Ci for the first shape means that the base will be parallel to y, and then it is 4. So bh cubed over 12 will be 4 times 1 cube over 12, and this means that it is 4 over 12, which is 0.333. And then here, guys, since I have to find around y prime, then the parallel side is 1, so b will be 1 here, and then the Iy about the centroid for the second shape will be 1 times 8 cubic over 12. Alright? So it is 8 cubic over 12, which is about 42.6. And then instead of dy, I should find dx. This is the perpendicular distance between the centroid. And then dx, guys, will be what? Will be x minus x. So I will start by the first shape. X is 0.5 minus xc is 3.5, so it is 3. So here this should be 3. And then y of the first, and then x of the second shape, which is 5 minus 1, this should be 4. And then you do the multiplication and then you find y prime. So guys, as simple as that, you should only memorize the moment of inertia of the regular shapes, put them in the table, using the steps, and then you can find the moment of inertia around any axis. Now guys, if the question is only to find the moment of inertia around y prime passing through the centroid, so you don't have to find ix prime, you only have to find iy prime, so you apply this table once. And if you have a whole, as we said, you should do the subtraction. And don't forget guys, if we have a symmetry around, let's say, y prime, so there is a problem in the PDF where I have a symmetry around y prime, let's say I have a U shape. So guys, if I have a symmetry, this area is equal to this area, then the centroid will, of course, lies at x is equal to the whole length over 2. So you don't have to find x of the centroid, alright? You only have to find y of the centroid.
So like this case, this is a U shape, for example. So in this U shape, guys, of course, you should find first the centroid. This is the first step, so you don't have to find x. You can only find y because x lies at the middle point of this beam. Now, in fact, in this example, the question is only to find the moment of inertia about the centroidal x-axis, so around this x-axis here. So that's why you should find y, and then you can find dy, which is x minus x. So guys, don't forget, dy is x minus x, dx is y minus y in absolute value. And of course guys, I want you, in order to finish all the problems of this chapter, to do the same for an I shape. So you have a lot of beams where the cross-sectional area has an I shape. So I want you guys to apply the same steps for I shape in order to find what is the moment of inertia, and you will find the solution also in this PDF. Thank you.